Hello everyone, my name is Edgar Solis Romeo and I am going to talk about FPGA solutions for machine learning. What is an FPGA? FPGA stands for Field Programmable Field Array. It is a device made out of semiconductors that can be configured after being manufactured. This characteristic gives FPGA the advantage of allowing flexibility in its design, which saves time and costs at the moment of introducing changes to it. FPGAs consist of programmable logic elements that are connected one to another. They are also equipped with memory blocks. FPGA stands in contrast to ASICs, which are application-specific integrated circuits, and SSPs, application-specific standard products. ASICs, as their name implies, have a specific customized particular use. This means that they are designed with a particular functionality in mind. ASICs usually are sold to a specific user, and ASSPs, while also having specific use, are sold to many users. Having stated this, we can see that the three of them are integrated circuits, with the main difference being that FPGAs are configurable, while ASICs and ASSPs are not. Now I'm going to talk about neural networks. Neural networks are systems composed of at least three node layers: the input layer, the hidden layer, and the output layer. Each node is a neuron that uses an activation function. An activation function is used to determine the output of the node, given the inputs coming from the previous layers and the weights assigned to them. The design of neural networks require forward and backward processes. The forward process focuses on the amount of layers and the flow of the input and output information, while the backward process focuses on defining the loss function to calculate the gap between the prediction value and the actual values of the data samples during the training phase. The result of the backward process is used to alter the weights given to each node to make the final output more accurate. When the system runs a forward and backward process, it is known as an epoch. Neural networks require hundreds of epochs of training to reach high levels of accuracy. Why use a FPGA for designing neural networks? Currently exists a push for developing machine learning algorithms in FPGA systems. To be more specific, attempts are being made in using FPGAs to implement neural networks. The reason these systems are being developed is to reach the goal of creating a semi-custom high-performance system for neural networks that is able to outperform conventional processors. There have been different attempts to make advances toward this goal. The results have shown that FPGAs are outperformed by ASICs and general-purpose processors. This may be discouraging for the previously stated goal, but a consideration must be made also for the fact that the structure of a FPGA presents an alternative to the software in a general-purpose processor, thus providing the possibility for delivering a superior performance in relation to cost and energy consumption on specific applications. This can create the impression that ASIC systems offer a better alternative for the development of efficient neurocomputers, but in fact, this is not quite true. Two important reasons that have to be taken in consideration regarding FPGAs being a better alternative to the idea of developing ASICs for beating general-purpose processors in performance. Now, the first one being that when developing ASIC neurocomputers with a significant amount of flexibility, the final result is a system with a structure that closely resembles a FPGA, while never reaching the flexibility that a FPGA can attain. This is important because neural networks require to be easily reconfigured, since they are meant to be used for different applications. The second fact is that the design and production of custom neurocomputers has a limited user base, thus the development of the software for ASIC neurocomputers will lag behind FPGAs that will be more widely used. Now, another factor is parallelism. Another of the reasons for the drives towards the use of FPGA for creating neural network systems is the perceived capacities that this technology has in the realm of parallelism. Parallelism is a feature that allows to run two or more computational processes at the same time. FPGAs are more suitable for parallelism than ASIC systems. These capabilities are suitable for working with neural networks. To better understand this, we can take a look at different types of parallelism applicable to this topic. The first one is training parallelism. This refers to the idea of going through the nodes of each layer of the neural network in parallel, and this could be a great advantage for a FPGA system. It is necessary to take into account that neural networks can have up to a million nodes, and a system with that high amount will face limitations that will not allow it to reach those high levels of parallelism. Another promise of the FPGA systems is the idea of computing the layers of the neural network in a parallel way, but the possibilities for this are low, since it required the input from the output of the previous layers. So results of different implementations of this system. The implementations of neural networks in FPGAs is a developing field that is already giving results as different researchers try to find an efficient application for a machine learning system using this technology. One example is Lu Liqiang and company's attempt of implementing the Winograd algorithm for more efficient creating matrices to analyze images with neural networks using specific FPGA system from the Xilinx family. This experiment tested their implementation and compared it to the performance of a Titan X processor. The result being that the FPGA's performance was way more efficient. This is an example of the possibilities of FPGAs, and although this is a field that still needs further development, the results of it are already being noticed. So here we can see some of the results from the Titan X and the FPGA system that was tested in the research that I mentioned. And I think that FPGA is a promising field in the field of developing neural networks. And I think that it is important to focus on this, and in the future there will be more advances. So thank you for your attention. Here is a list with my references. And again, thank you for your attention. Have a good day.